In this video, we're going to look at another analytical geometry question from start to finish. And so what we've got in the beginning is we've got A, B, C, D are the vertices or the corners of a quadrilateral. We don't know what type it is yet, such that the diagonal AC is perpendicular to BD. So immediately my brain is thinking I might use Pythagoras at some stage. I'm also thinking if I've got the gradient of one of these lines, then I can get the gradient of the other line. So that's all going through my mind before I've begun. The equation of BTD is given by 2y plus x is 18. So what that's making me think immediately is let me try rather rearrange that so that I've got it in standard form. And that's a good practice before you begin questions. And AB is 15. So let's dive into the questions. Determine the gradient of AC. So if this gradient now I can see is minus a half, then the gradient of AC will be 2. The way that you get perpendicular gradients is the one gradient times the other gradient should equal minus 1. Therefore, the gradient of AC, if I times that up, will just be 2. Calculate the equation of AC, y equals mx plus c. So if I know that the gradient is 2, I can start by saying y equals 2x plus c. I'm missing one letter. What I do whenever I'm missing a letter in graphs, I sub in a point. And so I sub in a point on AC, so that will be A. And when I sub that in, I get minus 5 equals 2. The x is minus 2 plus c. That becomes negative 4. And when I plus that across, c equals negative 1. So what's the equation? It's y equals 2x minus 1. If the equation is 2x minus 1, praise the good Lord, we know that we're correct. Calculate the value of t. T is just the point of intersection, and at intersection, what I do is I just make the equation of the two lines equal. I make the equation of the one line equal to the equation of the other line. That's all that I do for intersection. This goes across and becomes 5 over 2 x's. This becomes 10. And if I take this across, I end up with just getting x is 4. They ask for the coordinates of t, so I know that the x is 4. What do I do whenever I'm missing a letter in graphs? I just sub in, and so I'm going to sub 4 into whichever graph looks easier. So this one looks easier for me. So if I sub 4 in there, that becomes 8 minus 1 is 7, and so there's my point for t. You really want to be quite fastidious, quite careful with analytical geometry so that you're not using incorrect answers just because you took things across casually, because questions typically follow on to the next ones. If ABCD is a kite with AB equals BC, so let me immediately fill in that these two lines are equal and these two lines would be equal, and we know that the diagonals bisect at 90. So as you find out information, just fill in as much as you can to make your life easier. And we know that t is 4 and 7. Calculate the coordinates of c. And so one thing with the kite is that these diagonals bisect here. Not these ones, but these ones will bisect. And so I can just use midpoint formula to get c. And so how does that look if I've got the midpoint? So the midpoint formula, I don't know c at all, so let's just call it xy for now. It will be the x value at the one point plus the x value at the other point over 2, and the y value at the one point plus the y value at the other point should give me my midpoint. But in this case, I know my midpoint. The x is 4 and the y is 7. So you can set it up as two little equations here. I'm going to times the 2 up, and then I'm going to take it across, and x is 10. And I'm going to times this up, so that becomes 14, and I take the y across, that becomes 19. And so my coordinates of C, to finish off the question, would be 10 and 19. Calculate the length of BT. And so what you can do to get the length of BT, seen as you don't know B, is you could work out the length of AT, and then because you have a 90 degree, you can do Pythagoras. And so let's do it up here, 3.4.2. Let's work out the length of AT using the distance formula because it's a length. So the change in x would be 4 minus, in brackets, minus 2 squared plus 7 minus, in brackets, minus 5 squared. And that will give you an answer that's not pretty, but of square root 180. And then if you're trying to work out BT, BT squared will equal the hypotenuse squared minus AT squared. BT squared, AB squared is 15. AT is square root of 180. That will just leave me with an answer of 45. And so just getting BT, it will be square root 45 or 3 root 5, however they present it to you. Last question, calculate the length of the radius of the circle passing through B, C, and T. And so what does that mean? What it means is that you've got a circle passing through, and if you've got a 90 degree, I'm just going to overemphasize it here, then opposite the 90 is the diameter. And so that's what they're trying to do. They're trying to see if you know that rule of angles in semicircle. So if I've got the 90, opposite is the diameter. That means that the diameter is 15. So BC is the diameter, reason, angles in semicircle, and that equals 15. Therefore, the radius, I just divide that by 2, and there you've got your answer. I hope that you found this video helpful. If you did, please like it, subscribe to our channel, and share this with your friends. Thanks.